Hello everybody, my name is Isabel Ballesteros. I am product manager of the Sunny Island X, and I want to show you today how to calculate an off-grid system in Sunny Design Web. Sunny Design Web is a free software offered by SMA, and after you register, you can use that in your browser. So once you are in, you will see that there are different possibilities of projects. In this case, I will choose the off-grid system. Once you are there, you need to choose the project name, for example, example 1. Then the status is new, customer name. You also are able to upload images, to upload your logo, give some, several points, because after that you can download the results and show this informed to your customer. So a really important thing is, before we start, to choose the location, because looking for having the location, we have the meteorological and irradiation data we will use for the calculation of the PV size. So I don't like to choose the irradiation data from Germany. I will choose some anywhere a little bit in the south. So you can write the name of the place, or you can look for in Google Maps, like I'm doing here. And after you are here, you can just click on your in the right taste of your mouse, and the place is selected. So once you select the place, it will look for the meteorological data, the dates of the irradiation. So in this case, it offers me to use the data from Middle. I will choose Urasasate. I'm not sure if I'm spelling it good, just to show you that I can use another meteorological data. In any case, I will compare the data from here, from this city, to these ones in this global solar atlas, or another one if you have another program. Just compare the data and choose the place that come closer to the meteorological data of the place you have choose. So the next step is to choose the electrical type of the system. In this case, it's 3-phase, and the location settings. In this case, I'm in the mountains, or this city is in a high place, so I can edit. For example, if I have noted this, if I know that with the altitude I can have different temperatures. So let me choose this one with 1,500 meters above the sea level, and of course you can adjust the temperature settings. And an important point to adjust to are the yield losses. I will choose everyone just to take in account these losses. And I will go to define the load profile. To define the load profile, there are different possibilities. We have SMA offers some load profiles. For example, let's choose this commercial business, and it's an agricultural business with daily farming that has this consumption per year. And you can see the profile information. So it's less consumption. I see around 5 kilowatt peak in the morning and in the evening. So if I want to use this profile every weekday, it's same, but my demand is higher, you can just adjust the demand here. Just let's put some kilowatt hours more per year, and then you will see in the information that these loads increases automatically. So it adjusts the load profile to the energy demand you gave. So this is one possibility. The other possibility is to upload a load profile from an Excel data. So in this case, you can import the data. It's important to give the number of data you import. For example, if you give the data from a year or just for a week, and the interval minutes of the data you update, it can be 15 minutes, can be 1 hour, and all of that. There's one possibility. Another possibility is to import data from Sunny Portal in case the system is there in the portal. It's not a problem. You can do that, or create consumption data. If you click about create consumption data, you have different possibilities. For example, I have here only at the two load profiles where the difference are between week or weekend days. But you can add several profiles more. Just clicking above this add new daily load profile and make difference. For example, here I will just the weekdays during summertime. So now these ones are this profile is just for these days. This just for weekends around the year, and this only for summer. Every time that you want to have different profiles, just add one using this button. And if you want to adjust the profiles, just click above this gray field, and you need to write every hour. So you need to give 24 values. The demand, for example, here, then here. So every day you should adjust the consumption data. So, but in this case, I will cancel and I will go for my own load profile. I have a real profile. So I will show you the profile information. In this case, in the morning, there's a small peak. Then during the day, the people is not at home and they came in the afternoon and start to cook and so on. This is not the perfect one. That's why I choose that, because a perfect profile is when you have the demand here in the middle of the day, like the irradiation. But yeah, in this case, we need to save the energy from this middle of the day in the batteries to be able to supply this load in the afternoon. And I need to adjust the specification of peak load. It calculated it automatically. So it calculated first this 274.9 kilowatts. In my case, I will go up to 350 kilowatts. Why? Because this will be the minimal number of sunny islands that the system calculates. So in this case, 350 kilowatts means that the loads or that the sunny island, the number of sunny island will be 7. Why? Because every sunny island has 50 kilowatts. So 7 times 50 are these 350 kilowatts. So, but let's calculate and let's see if I will get 7 or more. I mean, 7 will be the minimal number. So I go to calculate the PV system. I use always the manual planning, and I go through the system assistant. Just one point. I just want to calculate the size of the PV. If you want to calculate the rates work between PV inverter and PV module, just please look for the module, looking for the manufacturer. There's a huge database with a lot of modules. Just look the model and just look the look for that. And once you know the size of, once you calculate the size of the PV system, you can just adjust the PV plant or the PV inverter to your module. But in this case, I will use a standard one just because I want to know the size of the PV. So I go to the system assistant, and it opens this window. Then once I have this window, I said that I wish to have an autonomy time of 12 hours and to cover at least 80% of the total energy demand of the year. I mean, here's for the complete year. If I click above here, I can design, I can make my design based on the worst month. Then the solar fraction will cover 80% of the worst month. In this case, I'm calculating for the whole year, okay, an average. So I click to calculate a proposal, and this is my first proposal. And then I go to the next steps. So I go first to the next steps, and then we will adjust, okay? Then I apply the proposal. I see I can use 5 of this sanitary power 125. I adapt the design, and then this looks good. Afterwards, I can go to see the battery, So in this case, it offers me 10 sunny islands with this battery size. Of course, I can adjust the battery size. I can also look for, I have a big database of batteries. There are BYD, BioNTech, Sunwoda, Tesla. So I have this database, and I can choose the battery size that goes that come close to this, the battery size that the system calculated for me. And then after that, I can go to the genset configuration. Sorry. Sometimes with the diesel configuration happens that the generator is already on site, or that the size of the generator is not the same as the one that are the models that are in the market. So you can adjust this here. So for example, I will use a 1 megawatt generator. I need to, this is an important point, I need to adjust the minimal capacity of the genset. It means that the genset will never work below this percentage. So it means that if I set 20%, the generator will always work above this 20% of minimal load. I also need to adjust the efficiency, the liters I need per kilowatt hour at 100% power, 75, 50, and 25%. And this is really important to adjust. Please take a look to know these values in the data sheet of the generator, because knowing these values, I can calculate the liters of diesel I save. So I click to OK. And then you have seen it, this file moved a little bit. And then the next step will be cable sightseeing. I won't stop here. I just want to say you that you can calculate the cross section of the cables depending on the length. So if you know the distances, you can do it with this program. The important point is that this losses keeps below 1%. And then I go to the analyze of the load. So in this moment, first of all, I calculated with 80% solar fraction, and this is what I wanted to have. But the system made a first calculation with around the 60% of the solar fraction. So it means that my energy consumption is 1.5 megawatt hours, but my available PV energy is below. You can see that. First of all, I will increase the PV just to go above this value, because in this way I can have more for this energy to supply my loads. Second of that, but this never happens, is that the consumption moves to the middle of the day. If it is possible to move the demand to the middle of the day, then we can cover a little bit more, because if you can see, you used 950, around 950 megawatt hours directly, and the rest will be saved in the batteries. But I want to keep this value a little bit higher, so I will try to increase PV plant and battery size to go a little bit up with the values. So I can go back to PV system here, and I will increase the system to the 1 megawatt. Okay. So in case the peak power, I will go to 1 megawatt. As I say, you can also calculate it within. I have here a standard PV module just for the calculation, but you can also adjust it with the module you have. And then you can see it doesn't work. I need to increase the number of PV inverters or delete it and make a new calculation. I will go first in this way. It's still above, it's a little bit above the number of nodes I gave, but I will choose this one just to go through. So I have a little bit more than a megawatt. It's not a problem. It's possible. You can also double check the inputs and the number of modules per input and so on. The nominal AC power of the PV inverters is in comparisons to the power of the battery inverters is more than 1.5. So we should keep in this green line. So it means that I need to increase the number of sunny islands of battery inverters to go down with this ratio. So I go to battery system, and I need to increase the number of inverters. I will put, first of all, I need to change the box, and then increase the number of inverters. And now the ratio looks good. You see, the nominal power of the PV inverters divided by the nominal power of the battery inverters keeps below 1.5. So what is the problem now? I increase the number of sunny islands to 14, but I didn't change the size of the battery. So I increased 4 devices with 4 batteries in the same size. So the system now has a lot of autonomy time. I wanted to keep more or less by the 12 hours of autonomy time. But as you can see, the average of annual solar fraction goes up. What I will do is, what you should do in this case is just to find the midway between too much battery that is expensive, but it saves a lot of diesel, or to keep a good balance. So I will go a little bit down with the battery. I will go to 250 kilowatt hours per sunny island. Still, there's a little bit more of autonomy time that I wished, but as you see, decreasing this capacity in each battery, I went down with the annual solar fraction to 88%. If you wish, depends a little bit about how much the customer wants to spend in the system, but a good battery should be at least I calculate always with the time I need to feed the battery. So if I have a Sunny Island 50 with 50 kilowatt of nominal power, I need, if I work with a full capacity, I need at least 5 hours to feed the battery at nominal power, or to discharge the battery at nominal power. So this is a good average, 5 hours of full power. As you know, we don't use the complete battery, it will be less than 5 hours, but it's realistic. I will never use a battery that is for example, 600 kilowatt hours. You can use that, but it doesn't make sense, because it means that you need to charge this battery during 12 hours at nominal power. It never happens. So the battery will never be fully charged or fully discharged. So it will not keep a full cycle. So my recommendation is always between minimal 2 hours. It means 2 times the nominal power of the Sunny Island, 100 kilowatt hours, and maximal 350 kilowatt hours. So between this value makes sense. If you need more capacity, just add Sunny Islands, because it is better for the battery to keep it working in full cycles. So here now I can decide if to increase the battery or not. I will go down maybe to 230 kilowatt hours, just to go to this 13 hours. But as you see, just for this 20 kilowatt hours per battery, I went 80% down. So let's increase it a little bit. Yeah, well, now it looks better. And you have the possibility. Then I go again to see the analyze of powers. And then I see here that from more or less with this calculation I made, it's around 80% of average of annual solar fraction. I can be from around September up to March, April with my system without the need of the generator. So you can see here the solar fraction. You can go to the overview of the results. Compare all the results, see the liters of diesel you save or you consume with this kind of system. And then you can go to project documentation and download everything and explain and give it to your customer. So Yeah, and with that, I am ready. Thank you very much and have a nice day.